Hello and welcome to a lesson on an introduction to algebra. In this lesson we're going to talk about some key vocabulary and just a few things that'll help us get started as we move forward. So let's start with algebraic expressions. An algebraic expression is a combination of numbers put together with variables. So it's numbers and or variables, or putting the numbers and variables together. And those numbers and our variables are going to be separated by math operations. And there are four math operations that could separate our numbers and or variables. Those four math operations would be add, or subtract, or multiply, or divide. Okay, so we separate numbers and or variables with those math operations. We have an algebraic expression. Now, the parts of our algebraic expression that are separated by just the plus and minus signs, the parts that are separated by addition or subtraction, those are referred to as the terms of the algebraic expression. So depending on how many things are being added or subtracted will tell us how many terms we're going to be looking at. And the terms in the algebraic expression that don't have any variables, those are called constants. Okay, so just to wrap our brains around some of the vocab, for example, 1, if we're looking at something like 5x plus 3y minus 7, that is a perfect example of an algebraic expression. So the first two pieces we see, the 5x and the 3y, those are called variable terms. And then again, terms are separated by pluses and minuses, right? So what we're looking at is one term plus a second term minus a third term. So we've got three terms here. And again, these first two terms contain numbers with variables. So we would call those variable terms. So there are two variable terms. And then the third term doesn't contain a variable, so we would call that the one constant term. And again, that makes three total terms. Okay, if we're looking at something like number 2, we have to be a little bit careful. If you're looking at that, you might be thinking that you see three terms again. However, this 6 that's sitting right next to that parenthesis implies multiplication, and multiplication doesn't separate terms. In fact, it keeps things together. And so we would say that this is one whole term here, plus we have a second term here. So this would be two terms total, where this whole thing is one variable term. And I can't spell, sorry. One variable term. And then again, we have here one constant term. And that piece has no variable attached, so again, that is called a constant. And this would be two total terms. Okay, so these are just some samples of what algebraic expressions could look like. One of the first things that we'll be looking at doing mathematically here is evaluating algebraic expressions. If we're going to evaluate an algebraic expression, it means that we're going to substitute values in for each of the variables in that expression. So we're going to substitute in a value for each of our variables. Now we substitute in those values by replacing. When we substitute, basically we are replacing the variable we're given with the given value, and when we replace it, when we substitute it in, we want to make sure we use parentheses to do so. And after the substitution, after the replacement of those variables with their values, then we just compute a value for the expression, so we perform the operations. So we calculate, compute, perform the operations, any of those words really would do there. Okay, so for example, on number 3 it says to evaluate x plus y, so here's our expression, but it says to evaluate for x equals 51 and y equals 35. That means we're going to replace x with 51 and we're going to replace y with 35. So instead of x plus y, it's going to be 51 plus 35, where again the x got replaced with 51 and the y got replaced with 35, and when we replace them with parentheses. Now it doesn't actually do anything to this particular problem. The 51 plus the 35 without parentheses is really the same problem. In any event, we calculate this here and we end up with 51 plus 35 is going to be 86. So 86 is our answer. And By all means, use a calculator. Not that that's really difficult to do, but if if you're just unsure, or maybe it was a more complicated problem than this, by all means use a calculator. And Desmos is the one that I asked for you to download as an app or have access to online, since this is a free one that we'll all be able to use. This is the one that I will use when I model anything calculator-wise. And so if you just wanted to make sure that you can add, or maybe you just don't want to, there's our answer of 86. Okay? All right, same thing here. We're going to evaluate 3xy for x equals 12 and y equals 2. So we've got a 3, and then we're going to be replacing the x with 12. And so I'm going to put in parentheses 12 next to the 3 instead of x. And then we're going to be replacing the y with 2. And so next to the 12, I'm going to put parentheses 2. So instead of 3xy, it's 3 parentheses 12 parentheses 2. Now it's a little more important. You can see on this one, the parentheses, my gosh, sorry. The parentheses are a little more important because they tell us the operation that's happening there. So the number next to the variables implies multiply, and so do these parentheses. So we're multiplying 3 times 12 times 2. 3 times 12 is 36, and 36 times 2 is going to give us an answer of 72. And again, if you want to just use your calculator to do 3 times 12 times 2, that's going to work out nicely for you too. Okay, so 72 is our answer there. You may see an evaluation problem like this, the same concept here. It says, find the area A of a triangle with a base of 8 centimeters and a height of 6 centimeters, given that A equals 1/2 times base times height. So if you didn't know, to find the area of a triangle, we multiply 1/2 times base times height. So in this case, it says to find A when we know that the base is 8 and the height is 6. So we're going to be replacing the base B with its value, which is 8 centimeters, and then we're going to be replacing the height H with its value, which is 6 centimeters. And let me just make sure I highlight all of that. Okay, so we have A equals 1/2 times, in place of B, we're putting 8, and then in place of H, we're putting 6. And then it's just computation from there. So 1/2 times 8 is 4, times 6 is 24. But again, if you wanted to use a calculator, to put in the fraction, you're just going to use divide. So 1 divided by 2 will make a fraction of 1/2. Then you want to use your cursor to get out of the bottom of that fraction. And then we're putting in our parentheses 8 and our parentheses 6. And again, 24. So our area is 24. Technically, the units are centimeters squared, but I'm not so concerned about the units. And in fact, when you work on your practice in Canvas, you're going to enter just a numeric answer without those units. So the area is technically 24 centimeters squared, but when you're in Canvas, if you had a question like this, you would enter just the 24. Okay, don't put any units or like A equals or anything like that. Okay. All right, moving along. So evaluating, one part of our job for today, and then translating is the other part. So we should be able to translate words into algebraic expressions, and to do so we have to understand which words are implying which operations. So when we see words like sum, added to, plus, more than, altogether, increased by, those all imply addition. That's telling us to add our terms. Okay. If we see words like difference, subtracted from, minus, less than, take away, or decreased by, all of those imply subtraction. If we see words like times, product, of, those all mean multiply. And if we see words like quotient, ratio of, or per, we are looking at division. Okay, so for example, if it says to translate, if you have a problem that tells you to translate 15 more than a number, well, 15 is obviously the number 15. More than translates into add to, and then a number. Well, if we don't know what our number is, then we're going to call that number some variable, and I'm just going to use n. Although if you wanted to use any other variable, it would be totally fine. So 15 more than a number means add 15 to a number. Now 15 less than our number, we have to be a little more careful. 15 less than a number. So if I said I was, no, I don't want to use my age here. If I said my older son, was 15, and I said his brother was 4 years less, then to figure out his younger brother's age, you would have to subtract 4 from the older brother, from my older son, right? So 15 less means subtract 15 from. So we actually got to go a little backwards here. 15 is the number 15, but I'm going to put it over here. Less than, actually, let me lump all this together. Okay, 15 less than means subtract 15 from something. And then we're subtracting it from a number, which we're going to call n. So subtract 15 from the number. Okay. The product of a number and 8, product means multiply. So the product means multiply. And what are we multiplying is our number and 8. So our number, let's call that n. 8 obviously translates into 8. And product means to multiply those two things. So 8 times n with the multiplied dot there would be okay. You might also see parentheses used. So you could see n and then parentheses and 8. That's another way to say multiply. Or you could see both of those reversed. So you could have, goodness, too many options here. 8 multiplied by n in the other way, or 8 multiplied by n this way. And in fact, we don't actually have to put a multiply dot or a parenthesis if we have our number directly next to our variable that also implies multiplication. And so I'm going to give you one more round of options here. You could also say just 8 times n, like this, without the parentheses or the multiply dot. You probably wouldn't see the n and then the 8. It's a little strange to put that order, but I would say all 5 of those would be acceptable. And the reason we can change the order on number 8 and number 6 is because multiplication and addition are commutative. So here, I guess I didn't state on this one, but n plus 15 or 15 plus n would be the same. So if I had these reversed, it would totally be the same thing, right? Think about some actual numbers. If you had 1 and you added 15, you'd get 16. If you had 15 and you added 1, you would still get 16, so it doesn't matter the order we add. And that's true for multiplication as well. So if you multiplied 1 times 15, you get 15. If you multiply 15 times 1, you still get 15. Now the reason it doesn't work on number 7 is because subtraction is not commutative. So multiplication and addition are commutative. We can change the order in which we add or multiply and still get the same answer, but here it's not. So that's something more we're going to talk about later. So don't get too hung up on that. Just think of an actual number if you get stuck on which way to write the difference one is the one you got to be really careful with. Okay. The next one says the quotient of 3 and a number. So quotient is telling us to divide. What we're dividing is 3 and then our number. So we want 3 and we want our number. Obviously 3 is going to be 3. Our number, let's call that n. And then quotient means to divide those things. And so we could use a fraction bar to divide. That's one option there. You could also just use the division symbol. So you could say 3 and then divided by n this way. Okay, any of those would be options. And now I want to go through and put the word or on all of these. So it could be this guy, or it could be this one, or. Okay, so lots of options on some of these. All right. So translating into expressions is probably something you've done before. Translating into an equation works almost the same way, except an equation is actually a mathematical sentence. It's a sentence, so if you're translating from words into an equation, then you should see a period at the end of a sentence instead of just a fragment, which is what we would call an expression. So in your mathematical sentence that is an equation, it's basically stating that one expression is equal to another. So you should see an equal sign in the translation. Okay, it's one expression being equal to another. So for example, if you had something like 3x plus 1 equal to, not the same thing again. Let's say 3x plus 1 equals 5x plus 4. This would be an expression on this side. This would be an expression on this side. And then this is them being equal to one another. So this is an expression equal to an expression altogether. We call that an equation. Okay? If we're going to translate into an equation, it means we're looking for some word in our mathematical or in our sentence, right, that's going to give us the word equal, that's going to tell us we're going to make an equation. Not just a period for punctuation, but if we see the words is, was, were, are, those are all just different tenses of the word is, or represents, or total, or same as, or makes. Those are all going to tell us that we need an equal sign to make an equation of two expressions. Okay, so for instance, 10 more than a number, that's something that we just saw a second ago, but now it says is 2. So that word is separating two expressions to make an equation. So 10 more than means 10 plus, and 10 more than our number, let's call that n, and then our is, that's our equal sign, and it says 2, so let's put a 2 there. So 10 plus n equals 2. Or if we said n plus 10 equals 2, that is technically the same thing. Okay? The ratio of a number and 2 is 12. So the ratio, that's a way to say divide or make a fraction of the ratio of a number and 2. So the ratio means we're looking at a fraction, and it's a fraction of the number and 2. So n and 2 is in that ratio, and it says that ratio is, that's our equal sign, and this time it's 12 on the other side of the equal sign. Okay, and there it is. Don't even have to worry about solving today. It's just a matter of translating. Okay, so you've got just a handful of problems to work on in your first practice assignment. So give those a shot, and if you find yourself needing any help, then just reach out. All right, until next time, take care.